Hey, my name is Amir Ishaq, and this is a continuation of remote desktop control from part 1. And you'll notice that in part 1, what we did is we created a Electron app and a React app. What we did was we loaded the React app into the Electron app, and then we got the screen ID of the desktop or whatever multiple screens that you might have, but we got the ID, and then we sent the ID to the React app, which is the renderer, and we used get user media to get the desktop stream, and we got to view the desktop within our React app. Okay, so let us now go and have a look at what we are going to do in part 2. Okay, so when the Electron app starts, it spins an Express server with socket.io, and then it makes a request to the Express server to load the React app, and the client browser will also go through the same process. At this point, the Electron app gets the ID of the active screen and sends it to the browser, which is a renderer. Using this ID, the browser will call get user media to obtain the stream of the desktop. When the client browser starts, it will exchange SDP ICE candidates via the Signal server with the Electron app. And when all is success, the media will start to flow. We will also be using the signaling server to send the mouse events like mouse move and mouse clicks. So let's go ahead and start modifying our code from part 1 and try to achieve what we just mentioned. Let's start with adding the server dependencies. This may take a while, so be patient. Let's test again. That's good. Our app still works. Okay, let us now jump to main.js and make some changes to it. Let's import some modules for our Express server. The code that follows now is responsible for running our server. We are also going to use socket.io for our signaling between the two apps. I will in a short while change the port to 4000 instead of 5005, and there is no specific reason for that. We are now done with the server configuration. We now focus on the socket.io connections. At some point after successful connections, there will be exchange of SDP and ICE candidates between the two participants or the two clients. So let's go ahead and write some basic code for exchanging offer SDP and answer SDP as well as ICE candidates. Notice how simple the signaling is. For some reason, sometimes I get an exception on height as it being not a number. So I'm just putting a check over here. I'm going to send the first screen from the list of screens that we receive. Let's test again. Everything still works. Now let's jump to app.js and make the necessary changes. Let's import socket.io client and point it to the same namespace we defined in the servers. Okay, let us now add code that is going to be responsible for establishing our WebRTC connection. This is pretty straightforward, especially if you've already watched my other WebRTC series YouTube videos. We'll now comment out the assigning of stream to the SRC object and instead add to the stream within the RTC peer connection. This method will be used by the React app second client, and it will be the one that will create an offer and send the SDP to the Electron app. We will first set local description and then emit to the server to be sent to the Electron app. We'll now move some methods into the use effect so that they just run once. Okay, let us now add the socket events for when we receive an offer, an answer, and ICE candidates. Again, nothing new here. We've all covered all this content in the other videos of WebRTC series. We'll now assign the stream to our video element and play it as soon as metadata is loaded. If window.electron API is not null, then it means it's our Electron app, otherwise it's our browser, which is the second client that is connected. Now our app cannot work anymore on localhost, so I'm going to use ngrok to tunnel our application. I'm now going to have to build our React application and have it served via the Express server. Some typos to fix. Let's build and test again. We now see the screen in our browser. Now our ultimate goal is to control the desktop from remote. And for that, we're going to use robot.js. So let's go ahead and install it. This will take some time. Let's import robot.js. Let's declare a couple of variables. Let's add a couple more socket events. Let us now write the mouse move socket event. We will receive the X and Y position as well as width and height of the window. From the client selected screen, we will get the width and height of our desktop screen. For now, we calculate the ratio of the display width against the client's width, and then we're going to use that to calculate the host X and host Y. And that will be the position of the mouse on the desktop that we are trying to control. Now add the socket event for the mouse click. Second argument, when set to true, means double click. We get the display size of the selected screen and send it to the client. Let's make sure our application still works. Screen returns the list of all the displays and their properties. Let's import screen. We'll be getting the selected screen and call set selected screen to save the screen information to state. And via signaling, we're going to send it to the other client. Initially, I had wanted to use a canvas element, but then I figured out that it's easier to wrap the video element with a div. The div element will now be responsible for catching all the mouse move and mouse click events. Now let's add the mouse events. This, of course, is not the best solution. We probably need to find a way to drop frames. Otherwise, you'll experience the lagging of the mouse when it moves, especially when you have a slow network. There's an error. Let's look for the problem. Okay, so it's a typo, robot.js. Let's go fix it. Let's try again. And don't forget to build. Oh, I forgot to make a small update to the handle stream. So let's go and do that. Handle stream expects 2 parameters. Let's try and build and run again. Excellent, our app is running smoothly. Observe what happens to the mouse pointer. It works, but not exactly the way we want it to work. So let's go and modify the ratio we earlier on calculated. So we'll now calculate the ratio for X and for Y. Let's build and run again. I've just made it full screen so that we can see the whole screen. Perfect. Observe the mouse again. See the way it jumps? Basically, when we send the X and Y location of the mouse from the client to the Electron app, WebRTC moves the mouse to the right location. Let's run again. This time I'm going to use a different computer to control the mouse on the Electron app. Let's run again. I'm now going to use another computer to connect to this computer and control it. As you can see here, I have another laptop. I'm going to refresh. So I'm now connected, and as I move my mouse, notice on the other computer the mouse should also be moving. As you can see, okay, I'll remove the my video. I just clicked again. You can see that I'm moving around the desktop from the browser of another computer. So it's working fine. I'm now going to close the application from the other computer, and it's ended. Okay, let's try and run the application again to demonstrate the issue with the inner width and inner height, more so the inner height of the browser window. Okay, let's run. Okay, let's increase the height of the window or rather the browser. Let's refresh. So we get our screen that we want to control. Now notice that there is this space and we are using the inner height of this browser, which goes all the way from here to down here. So when it does the calculation, that basically when it calculates the ratio, this space will not be accounted for. So for example, if I move my mouse down here, see where it is, there's all this space that is not included in the calculation. Okay, so one way to overcome this, if you want to control your desktop from the browser, make sure the height of the browser is exactly the same as the stream that displays inside the browser. Okay, in there. Now if I move my mouse inside here at this location, then it is actually moved to the right location on the computer you're controlling. So I move in, doop, it's down there. See, if I go here, see, it's all the way down there. The same thing on this side. So doing it this way, the mouse is moved to the right location. All right. I hope this video was useful and thank you very much for your patience. See you again next time.